Bang origin be determined is the question. Can the Big Bang origin be determined?
Okay, well, I maybe should make it clear. I don't believe the Big Bang myself. So in terms of its origin, I think that's a problem. It's funny because the one thing the Big Bang does not explain is the origin of the universe. It's just a story about what supposedly happened afterwards. The idea is that the universe began as a point and then rapidly expanded, and then everything formed afterwards. So I would reject the Big Bang. It requires billions of years. It's got the order wrong. In the Big Bang model, you've got stars forming billions of years before the Earth, but according to the Bible, Earth's been on day 1, stars are on day 4. So the order of events is different, time scale is different, cause is different. I don't think that the folks who believe in the Big Bang have a unified position on its cause. Some would say nothing caused it. Some would say another universe caused it. Some would say it was caused by a quantum fluctuation, which I don't think really solves anything. So, yeah, I don't appreciate the answer with them.
Did you mention the 3 articles on your website?
Oh yeah, thank you. Yeah, I do have articles on the website that talk about this. There are 3, in fact, that I have on the Big Bang. I'll go through and I'll talk about the theology of it, the science of it, and the logic of it, and so on.
Okay, evolutionists prohibit any reference to God in their sciences, but if that changed and creationists did gain public acceptance in the world sciences, what should that look like in the classroom, in the lab, in the media, and so on?
Okay. Of course, there are some evolutionists who do believe in God. So there's some that believe that God used evolution. I think that's not consistent with Scripture, right? Because the Bible tells us that God He created animals according to their kinds. Apparently, that's the reproductive limit of an organism based on those that were selected to go on Noah's Ark during the flood year. If creation became more accepted in society, I hope it will be. I don't have a lot of hope for it being accepted in public schools. I'll just say this, somebody would be mad at me. I'm not a big fan of public schools, to be honest with you. Sorry, I get some applause. I get some people going, wait a minute. But public education is inherently contradictory because education, on the one hand, being public, it should be neutral. But education by its very nature cannot be neutral because even the selection of which topics are to be studied requires you to make a values assessment, and that's worldview dependent. And so it's interesting. It'll be interesting to see how much longer public education will continue. I think it will eventually cease to exist. I don't know that we'll see that in our lifetime or not, but it can't roll forever. It's like socialism. It can't work forever. You can have the Soviet Union for a little while and then it's going to collapse. And that's just the way it works. I would love to see in Christian schools, I'd love to see in home schools people teach creation, people teaching that it is in fact the foundation for science. That's something that I've really started emphasizing, especially in our ministry and our website. Creation is what makes science possible. The fact that God upholds the universe in a consistent fashion, that is at least partially accessible to the human mind, that we can probe using the senses that God has also given us. None of those things would make sense if the universe were an accident. And so science ought to improve as people start thinking about it in a more Christian fashion. In fact, the reason science has blossomed so much is due to large part Christian thinking. Most of the founding fathers of science, for the various fields of science, were Christians. In my own field of astronomy, a lot of Bible believers. They had their issues. Isaac Newton may not have held to the Trinity, okay? But he nonetheless was motivated by the Bible to make all the discoveries that he made. Johannes Kepler, very devout Christian, discovered the 3 laws of planetary motion and so on. So I'd expect science would flourish as people start getting back to the recognition that science stems from a Christian worldview.
What is your opinion on the age of the earth relative to an eternal God? In other words, God created the earth with a parent age. Adam and Eve were created as adults.
Okay, the universe was created in a sense mature. I don't use the expression appearance of age because it's actually what's called a reification fallacy, where you attribute a concrete characteristic to an abstraction. You cannot see age. Now, we use that term informally with people, right? People say, well, he looks 30 years old, he looks 40 years old. What we really mean is he has characteristics that are typically associated with a person of that age. But that's hard to say, so we shorten it. But the fact is, we can only do that because we sort of have a feel for how people, how the characteristics of a person change with age. You know that if somebody has a lot of gray hair, they're probably not super young. They don't have any hair at all, that might be another indication. If they have liver spots, there's certain physical characteristics that we associate with people aging because we have a large sample of people, and we kind of have a feel for how they change with time. We have one universe. What does a young universe look like? Apparently this one. Right? We only have the one data point. Likewise, for the Earth, in my view, all the planets are the same age, so they're all young. What does a young planet look like? This one. Now, I think there are indications that further would confirm that. But yes, the universe was created mature. There's no doubt about that. And so it didn't need time. In the same way that Adam did not come about from a baby, he did not need time to grow to an adult. But did he have appearance of age? No. If you'd asked Adam, how old do you look one day after he was created, he'd say, well, apparently this is what one day looks like. He would have no other data, right? And so our universe is like that. It was made mature, it was made functional, and it was not a problem for an eternal God to make it that way. God's beyond time anyway, so no problem for him.
Can you explain why Pluto is now not considered a planet?
Yeah, that's a fun one. When Pluto was first discovered, Pluto was discovered in 1930 by Claude Tombaugh, and it's very far away, right? It's farther out than Neptune, okay? So it's about 4 billion miles away, something like that. And it's very small, but when it was discovered, because it only shows up as a point, if you look at the photographs, and you can get these online, you can check them out on the internet, the discovery photographs for Pluto, and it just looks like a tiny little star. You can't see any size to it. And so astronomers have various techniques whereby they try to estimate the size of something when you can't actually see any size to it. And they have to make assumptions about how reflective it is and things like that. And they thought maybe it was very dark, and if it's very dark, that means it must be pretty big in order to be visible on the image. And so they thought, when they originally discovered, they thought maybe it was as big as Mars. Mars is about half the size of the Earth. It's small, but respectable, right? And then as improved technology came along, we realized Pluto is smaller than that, and then smaller than that, and smaller than that. We now know it's about 2/3 the size of Earth's moon. It's small. So it's smaller than any other planet by far. But the real kicker came in, I forget, it was around 2000 when they discovered another object out there called Eris. Well, they started finding other objects in the 1990s and early 2000s that were almost as big as Pluto in that orbit. Almost as big as Pluto. And then they found one that at the time they thought was bigger, called Eris. Do we add Eris? It's bigger than Pluto. It's at a farther distance. Do we add it and have 10 planets? If we're going to do that, what about these other 20 or so objects that are about as big as Pluto? Do we add those as well? Do we have a solar system that has 30 planets? Well, think of the children in elementary school that are going to have to learn 30 planets. Right? And so it became abundantly clear that Pluto is simply the largest member of a class of objects that are all out at that distance. And so for that reason, they said it makes sense to remove its status as a planet because it's much smaller than the other planets. And rather than add 20 new planets, make it the largest member of what we now call trans-Neptunian objects. By the way, it's not the first time this happened. In 1801, astronomers discovered a new planet called Ceres, orbiting between Mars and Jupiter. And then within the next year, they discovered 3 more. So there was a time when this was before Neptune was discovered. There was a time when our solar system had 11 planets. Yes. And then by the 1850s, they found another 20, all in between Mars and Jupiter, all small. And so they said, maybe we ought to call these minor planets, and eventually they called them asteroids. But the first 4 asteroids were originally classified as planets, and then they got Plutoed in 1850, right? Because they're small and there's a lot of them. So Pluto is small and there's a lot of them.
How do we know that the one-way speed of light is not a property of nature?
Okay, how do we know the one-way speed of light is not a property of nature? I suppose we don't know for sure, but everything that we do understand about physics suggests that you can make this one-way speed of light whatever you like, and all the physics works out. And that suggests it's not a property of nature. If it was a property of nature, we couldn't change it, right? But what John Linney demonstrated in the 1970s, he showed that all the physics of Einstein's relativity would work perfectly well, regardless of what we choose for the one-way speed of light. It makes no difference whatsoever to any experiment, or the result of any experiment. The number we assign to it might be different. Just like you measure a table in meters, you measure it in feet, you get a different number. It's the same table, right? The one-way speed of light's like that. It apparently is not a property of nature because we can choose it to be whatever we like, and we get the same observational experimental results if you're consistent.
What is the size of the universe, and how did the stars get there so fast?
Okay, we don't know the size of the universe. We know that it's really big. It's at least many billions of light years in radius, and it might go out further than we can see. There's what we call the visible universe, which is those objects that are within our range to see. What is the visible universe? The universe? Is there more universe that's beyond what we can see? There is what is called a cosmic horizon. It's sort of the four-dimensional equivalent of the horizon on Earth. You can see out to a certain distance, and if you're standing up, it's not very far. If you're out, like, let's say in Kansas, right, where the only thing that curves there is the very slight curvature of the Earth, you can see, I think it's like 1.5 miles. Standing up, that's all the farther you can see in terms of something that's on the ground. And you can't see beyond that because of the curvature of the Earth. Space-time might curve something like that. And so there might be more of the universe than we can see. In terms of how the stars got there, I think the stars were created roughly in their current positions. They've moved a little bit since creation because stars have velocity, but they were created at their current positions. And if I'm right about the starlight issue, then their light reached Earth instantly because of the way clocks are synchronized. God used the old style synchronization rather than our modern scheme.
So this one's a little outside of astronomy. Well, maybe not, but is there any evidence for meteors that killed off the dinosaurs?
Okay, that's a very good question. I don't think there's a lot of good evidence for that. The reason that, by the way, that's never been a majority opinion, even among secularists. Did you know that? The folks who came up with that idea kind of bypassed peer review and went straight to the media. And because it's a very exciting idea, it really caught on. But most secularists don't believe that the dinosaurs were wiped out by a meteor or a collision with an asteroid or comet or something like that. The reason that some do is because there's a layer of what's called iridium, which is an element that's not very common on Earth, but it is common in meteors and asteroids. Okay, and iridium there's a thin layer of it in between the highest layer that you find dinosaurs would be the Cretaceous, and then the tertiary layers above that. You'll find a thin layer of iridium, and you find dinosaur fossils below that layer and not above. And so some people thought, oh, there you go then. See, what happened is a big meteor hit and it spread that iridium out in the atmosphere and it fell down. And at that time the dinosaurs were killed, and that's why all the sediment that followed after that you don't find dinosaurs in because they're dead. Okay, so it's the iridium layer. That's the smoking gun for this meteor that killed the dinosaurs. One problem with that is in almost all sites that we've checked, we know of places where meteors have crashed, like Barringer Crater in Arizona, which I've been to. If you measure the surrounding sediment, it's not enriched in iridium. In other words, the meteor keeps the iridium in it. It doesn't spread it out. And so that's not a good explanation for what killed off the dinosaurs. Volcanoes, however, do spread out iridium. When a volcano erupts, it does have bits of iridium in it. And it does spread it out over an area. So we think it's probably, that iridium layer is probably more associated with volcanoes that would happen during the flood year and probably ended around the end of the flood year.
Just read it as it is. One smart apologist came up with the Kalam cosmological argument. The argument presupposes the Big Bang. This model is contrary to Scripture in a number of ways. Have you approached this gentleman for a debate on a more reasonable answer?
The Kalam argument. First of all, the Kalam argument has to do with arguing that the universe has a beginning and therefore a cause, and then usually they jump and say that cause is God. I don't use the Kalam argument except as confirmatory. Now, some apologists try and tie that into the Big Bang. They'll try to say, well, the Big Bang is the origin of the universe that the Kalam argument is talking about. William Lane Craig does that, for example. I disagree with him on that issue. I'd be very happy to debate him on that issue. Craig is not an astrophysicist. I don't know why he's jumping on the Big Bang as if it's true. It's not true. It's contrary to Scripture. He's a Christian, not at least in that. I'd be happy to debate him on the science of the Big Bang, too. I don't think the science is there. I'd be happy to debate him on either of those issues. I'm not doubting his salvation, but I think he's wrong on that issue is what it comes down to. So, and it's unnecessary because I think you could use a Kalam-type argument in a way that is consistent with the Christian worldview, but you don't need the Big Bang to do that. All you need is a universe that has a beginning, and really, nobody disagrees with that. Because the fact is, you can argue that the universe has a beginning on scientific grounds apart from the Big Bang. You don't need a false model of origins right, to try and build your apologetic argument. The fact that the universe has entropy is kind of a measure of messed upness of energy, and it's always increasing. And so energy is always going from a usable state to a less usable state. Now, if the universe were infinitely old, all the energy in the universe would have already reached an unusable state, and it hasn't. Therefore, the universe has finite age. Now, that's a good argument. It's solid. It doesn't depend on the Big Bang. Now, can you therefore say, therefore God? I don't think you can. I think it's consistent with God. Okay, and so I do use the Kalam argument in a way that's confirmatory of the Christian worldview, but not to prove the Christian worldview, because I don't think it works apart from the Christian worldview. That's my position on it. And then I would just encourage Christians, don't use a model of origins that is contrary to the Bible to try and prove the Bible. That's not logical. It's not moral either, really. Right? Some people might say, well, I'm going to show you that God exists using evolution. Well, but evolution is not true, right? I mean, what you lead people by is what you lead people to. If you lead people by an approach that uses false information, that says that you can reject the parts of Scripture you don't like, you lead them to a type of faith where they believe they can reject the portions of Scripture they don't like. And that's a problem.
These are two passages from Scripture in Joshua where it says the sun standing still, and Isaiah where the shadow moved back 10 degrees. How would you go about explaining those?
Oh, is that all? It's funny because I had a secular reporter one time in my office, and I had my computer simulation running. I had an Earth in the background. I had this neat computer simulation, the Earth rotating there, and he asked me that. Now he asked me it in a snide way. He's like, you're a Christian. Yeah. How do you believe that God just stopped the Earth on Joshua's long day? How did he do that? And I said, like this. And I hit that, and my Earth just stopped rotating. I said, now this is my simulation. I wrote this, and I can do that. Why can't God do that with his simulation? And he's like, oh yeah. Why would people go flying off? Do you think God would forget to stop the atoms on the surface of the Earth? He just stopped all the atoms of the Earth, and he'd just forget the tiny fraction that are on the surface, as if God was that forgetful? Come on. God can say, let the angular momentum of everything in this region be zero. That's not a problem for him. The Earth would just stop. Everybody on it would stop. Not a problem. That's apparently what happened on Joshua's long day. By the way, no, NASA computers have not confirmed Joshua's long day. That's a myth that goes around. That's not true. I know on the basis of Scripture that it happened. There are legends of other cultures recording a long day or a long night in the Americas, because they're on the other side. I need to look into that a little bit more, but that's kind of interesting. So, yeah, God can do what he wants. It's his simulation. He can stop the Earth. He can make it go backwards for a little bit, as he did with Hezekiah. Not a problem for him. The laws of nature are the normal way that God upholds the universe. He's not bound by them. He normally upholds the universe in a consistent way for our benefit. He doesn't have to.
Kind of along the same lines, are the solar eclipses over the U.S. in 2017 and 2024 warnings from God? I'm trying to think of a way to answer that. I don't think they're any more a warning from God than anything else that happens in nature. But the fact that nature happens, the fact that the universe is predictable, only makes sense in the Christian worldview. There's a principle in science called uniformity, not to be confused with uniformitarianism. I reject uniformitarianism, the idea that rates and conditions have always been constant over Earth history. That's not true. There was a worldwide flood. I do believe in uniformity, which is that there are basic patterns in nature that we would probably call laws of nature. The Bible describes those. The Bible, in fact, God promises that the cycles of nature will be in the future as they have been in the past. Genesis 8:22. As long as the earth remains, seed time and harvest, day and night, heat and cold, not going to cease, right? And all science is predicated on that. All science is predicated on the fact that if you do an experiment under certain conditions and you get a certain result, if you do the same experiment under basically the same conditions, you can get the same result. That's what makes astronomy possible. We all presume that the planets will continue to obey Newton's laws of gravity and motion, right, which are really God's laws. In the future, they have in the past. And that allows us to predict eclipses. So, in a sense, the fact that we can predict eclipses is proof of the Christian worldview, and the Christian worldview says judgment is coming. So in that sense, everything that happens in nature
is a warning that you better repent and get right with God, because science would not be possible if the Christian worldview were not true. And the Christian worldview tells us you need to repent.
All right.
What are the best, we've already kind of covered this, but maybe a repeat here. What are the best arguments against the Big Bang?
The best ultimately is the Bible, because we have the birth certificate of the universe. God tells us how He created it. He doesn't give us a lot of details, but the ones He does give us, we need to take seriously. Earth was made first, according to Scripture. Stars were made on day 4. According to the Big Bang, stars evolved billions of years before the Earth. According to the Big Bang, you have light immediately. You have very high energy. According to the Bible, darkness initially, then light's created, and so on. Then you have liquid water, according to the Bible, before you have light. That's opposite the Big Bang. Okay, so all the details are different. In terms of the science, I think there's a lot of scientific problems with the Big Bang. There are certain problems that are acknowledged even in the secular literature. Some of them they think they've solved, some of them are unsolved. There's the problem of the baryon asymmetry problem, which is the fact that if the universe really had sprung from a Big Bang, there ought to be an equal amount of matter and antimatter in the universe. Because when energy cools, energy can become matter under certain circumstances, but we always get an equal amount of antimatter. We know that from laboratory science. The kind of atoms they smash at CERN, Fermilab. You make matter, you make an equal amount of antimatter. And so if the universe was initially all energy and now it's matter, you have to have an exactly equal amount of antimatter. That's called the baryon asymmetry problem. That's a problem with the Big Bang. It's not a problem for creation, because the fact that the universe is essentially matter only with only trace amounts of antimatter, that's a design feature. Because if God had made it any other way, we wouldn't be here talking about it, because when matter and antimatter touch, they annihilate each other. So it's very important. It's a design feature that the universe is essentially matter only. Antimatter only exists in trace amounts, and it's created and almost immediately destroyed in most instances anyway. So there's lots of problems with the Big Bang. Check out those articles on the website. It'll deal with more of the science on how you refute the Big Bang.
Those articles are a very easy read. I would recommend them. This is a geology question. Did all the strata found in the Earth's sedimentary basins result from Noah's flood?
The Earth's sedimentary basins. I think no, but I think most of them were. I think most creation geologists believe that Cambrian and up. Precambrian we think is probably pre-flood. Precambrian is pre-flood. Cambrian and up through at least the Cretaceous would be flood year. Everybody agrees on that. All creation scientists that I know of, that are creation geologists, agree on that. And then there's some dispute about the tertiary, the two top layers, tertiary and quaternary. Those two layers, there's some dispute about where the flood ends. And part of the reason for the disagreement on that is the end of the flood might have been kind of gradual. That some places might have dried before other places did. I mean, that's certainly possible. And so there's some dispute about that. I tend to think it's probably, I used to think that it was right at what they call the KT boundary. Now I think it might be a little bit higher than that. So but basically the layers Cambrian up through Cretaceous we think are flood layers. And then tertiary, it might be late flood, early post-flood, and then quaternary is modern. So most of them are flood, but not all.
Can or does the medium through which this light passes, whether it's air, water, empty space, affect the speed of light?
That's a good question. The answer is yes. And I didn't bring that up just because it's a complication that wasn't needed to explain in the anisotropic synchronous convention. Yes, the material will affect the round-trip speed of light, not just the one-way speed, but the round-trip speed. Light is at its fastest in vacuum. That's where it travels a round-trip speed of 186,282 miles per second. In any medium, at least the informational speed of light will be less than that. In air, it's just a fraction less, like 0.999, whatever it is in vacuum. It's a little bit less in glass, a little bit less in water. Diamonds, it's only about 50%. Light travels at about half the speed in diamonds, which is why they're so sparkly, because that's what causes the refraction, actually. And so that's how you can tell the difference between diamonds and glass based on the refraction angle. So yeah, light will slow down in the substance. And then there are certain substances that scientists have created that are designed to slow it way down. There have been some where they've designed it to slow down at the speed about which you could ride a bicycle. So it's pretty amazing that they can do that with certain substances. And then there are certain substances where you can get the phase waves to move faster than c, but the group wave still travels at something less than c. So yes, the informational speed of light is always at its fastest in a pure vacuum.
How do you know that the speed of light makes a round trip?
Well, because I see it, right? So if I'm sitting here with my flashlight and it bounces and comes back, I see it. So most of the experiments that have been done to measure the speed of light are either round trip, well, all of them are either round trip experiments, or they make an assumption that makes them round trip experiments. A lot of people think, well, the first experiment to measure the speed of light successfully was done with Jupiter's moons. And it seems like it's a one-way experiment because the light only had to get from the moon, Jupiter's moons, to the Earth to see it. But Romayer, who did the experiment, assumed that the time was unaffected as the Earth orbited around the Sun. And so he's tacitly assuming that the speed of light is the same in all directions. But the fact is, most experiments that have been done are round-trip experiments, and all of them tacitly assume a round-trip speed of light. You can't measure the one-way speed without first assuming it.
I'm going to ask one more question since we're already a bit past our ending time, and I still have a couple of things I want to share with you about our group. So could you comment on the hypothesis that the speed of light has been reducing on a bell curve, I guess, over time?
Yeah, it's something I looked into. I don't think there's good evidence for that. I really wanted that to be the case because that was just a neat idea. But I looked into it, and the problem is the experiments that were done for the speed of light in the past tended to have quite large error bars, and so there was quite a lot of flexibility in what it could be. I don't think there's a good systematic. I've heard the claim. I've read there's some creationists that have jumped on it and said yes, the speed of light's been decreasing historically. I don't think there's good evidence for that. And today we can measure it just incredibly precisely. We can measure it to many decimal points, and there's no change at all. And if it were like an exponential decay, that wouldn't be the case. In nature, you don't find too many things that decay and then they suddenly go flat, right, where they just don't decay at all. So today the speed of light is extremely constant, and I don't think there's good historical measurements that it's ever been different.
Let's thank Jason.